We all know plastic floats on the surface, but what if we told you it sinks too? Ocean plastic pollution doesn't stop where the eye can see. It's been found in the deepest trenches on Earth, contaminating ecosystems we've barely explored. Don't forget to like this video, subscribe for more environmental insights, and let's uncover just how deep the plastic problem really goes. 1. Plastic is found at every depth. Plastic pollution is not confined to ocean surfaces. It penetrates all depths of the sea today. From floating bottles to sunken nets, plastic moves through all ocean layers and ecosystems. Currents carry debris downward into the mesopelagic zone, hundreds of meters below the light. Researchers have discovered plastic at depths of over 10,000 meters in deep ocean trenches. Even the Hadal zone, once thought unreachable, is now contaminated by plastic fragments. The deeper the plastic goes, the longer it stays trapped and undisturbed by surface activity. Pressure, cold, and darkness do not stop the plastic. It persists and infiltrates every level. 2. Deep-sea sediments are littered with plastic. Ocean sediments are collecting massive quantities of plastic particles, unseen from the surface. Researchers have sampled deep seabeds and discovered shocking amounts of microplastics there. One study found over 1.9 million pieces of plastic in just 1 square meter of deep-sea sediment. Sediments near continental slopes are especially rich in trapped plastic fibers and fragments. These areas act like underwater landfills, catching plastic that sinks through marine snow. The plastic often settles alongside organic matter, confusing scavengers and bottom dwellers. Once in the sediment, plastics can stay buried for centuries without breaking down completely. 3. Deep-sea animals ingest plastic. Plastic particles are now being found in deep-sea creatures living at extreme ocean depths. Amphipods, worms, and even deep-dwelling fish have been found with plastic in their stomachs. These animals consume microplastics accidentally while sifting through sediment for nutrients. Ingested plastic can block digestion, introduce toxins, and reduce energy for reproduction. Organisms that survive in low-energy environments cannot afford added stress from pollution. Some species only reproduce every few years. Pollution could wipe out generations silently. Scientists have discovered plastic fibers in over 90% of deep-sea amphipods sampled. 4. The Mariana Trench is contaminated. The world's deepest point. The Mariana Trench is now home to visible plastic waste and fibers. At nearly 11,000 meters below sea level, a plastic bag was filmed drifting in the trench. This discovery shocked scientists and symbolized the true reach of plastic waste today. It confirmed that no part of the planet is remote enough to escape human pollution anymore. Researchers have also found microplastics in trench-dwelling amphipods and sediment cores. Even here, plastic has infiltrated a world previously untouched by surface ecosystems. Organisms that evolved in darkness over millions of years now face synthetic intrusions. 5. Plastics hitch rides on marine snow. Marine snow is a key process in transporting plastic to the ocean's deepest regions daily. It consists of dead plankton, fecal pellets, and organic debris sinking through the water column. Microplastics attach to these particles and hitch rides to the seafloor during this descent. This turns natural ocean cycles into pollution pathways, delivering plastic to the abyss. Plastic arrives alongside nutrients meant to feed deep-sea communities and bottom feeders. Once attached, these plastics become part of the food supply for deep-living organisms. The ocean is constantly moving plastic downward in a quiet, unrelenting vertical current. 6. Ghost gear haunts the abyss. Discarded fishing gear like nets, ropes, and traps are some of the deepest plastic pollutants found. These ghost nets drift downward and become entangled on coral, rock, or underwater structures. Once submerged, they trap marine creatures that venture near them, including deep-sea animals. Ghost gear often weighs hundreds of pounds and sinks rapidly to the ocean floor unseen. These objects persist for decades, entangling life and disrupting habitats with synthetic mesh. Unlike surface nets, sunken gear is rarely retrieved due to the difficulty of deep-sea recovery. Many ghost nets are located thousands of meters underwater and remain invisible for years. 7. Cold water corals are under siege. Cold water coral reefs exist in deep, dark waters and are essential to deep-sea biodiversity. Plastic debris has been found snagged on these reefs, damaging their fragile branching forms. These corals grow incredibly slowly, sometimes only a few millimeters per year in cold depths. Plastic can block feeding currents, introduce toxins, or cause abrasions on coral surfaces. Ghost nets and trash wrap around coral mounds, breaking delicate structures as they shift. Unlike tropical reefs, these cold water reefs are out of sight and often unmonitored. Their destruction may go unnoticed until entire ecosystems vanish due to pollution stress. 8. Deep currents spread plastic. Ocean currents at great depths distribute plastic globally, linking remote trenches and basins. Thermohaline circulation, the ocean's deep conveyor belt, moves water and pollutants alike. This slow, global current pulls plastic through unseen underwater rivers across continents. What enters the sea in Asia can reach the Atlantic deep zone in a matter of decades. Microplastic fibers have been discovered far from human presence thanks to these currents. Plastic has become part of global ocean circulation, drifting unseen beneath the surface. These currents allow for the slow but steady contamination of previously untouched zones. Plastic is now a constant passenger in deep ocean flow, embedded in the planet's fluid motion. 9. Plastics resist deep sea decay. Deep sea conditions should aid degradation, but plastic remains intact for decades or longer. Cold, dark, low-oxygen environments slow bacterial breakdown needed for plastic decay. The result is that plastic objects stay chemically stable and physically unchanged underwater. Bags, bottles, and containers found at depth often resemble recent trash despite years submerged. The deeper it goes, the more time plastic survives without visible wear or biological decay. This permanence turns deep ocean zones into final resting places for unbreakable garbage. The seafloor is not a compost bin, it is a preservation chamber for synthetic pollution. Plastic can sit beside ancient fossils, mimicking the durability of natural geological layers. 10. Deep sea plastic is nearly impossible to remove. Plastic at great depths is far harder to remove than debris on beaches or at the surface. Recovery missions require specialized submersibles, funding, and extreme risk to equipment. Cleanup technologies are still designed for floating trash, not sediment-embedded pollution. Much of the deep-sea plastic is microscopic and invisible to human eyes or sensors. The logistics of filtering plastic without harming deep-sea life are nearly impossible today. Many deep zones remain unmapped, making location of waste difficult and uncertain. Disturbing sediment during recovery can release toxins or collapse sensitive ecosystems. No cleanup effort currently exists that can scale to the depth and spread of deep plastic. Plastic has reached places sunlight never does, and that's a terrifying fact. From surface swirls to seabed sludge, the damage runs deeper than most realize. Don't forget to like this video, subscribe to stay informed, and share this with someone who still thinks plastic is just a surface issue. If we don't act now, the ocean's depths may never recover.